I want to thank Rob Martin and the Raleigh ISSA chapter for letting me give this talk. I gave this talk at Triangle InfoSecCon, but it was a lightning talk, so I didn't get through the whole thing. There's a list of items that we typically go through at the end of this talk that takes roughly about 15-20 minutes. Really serves as a checklist too. I'll make sure that the chapter gets a slide deck, at least a PDF version of the slide deck, so we can post it too. Just show of hands, whose organizations are leveraging containers for any purpose, including microservices? Just okay. Who is hosting on host operating systems that they manage themselves as opposed to serverlessly, like a Fargate? Okay. Yeah, so this is more relevant to that use case. Obviously, when you start to host containers serverlessly, then you're relying on the cloud provider to manage the underlying infrastructure, monitor that underlying infrastructure. There's some things you can still do, but some things that are probably not technically feasible, right? So today I'm going to provide you with an overview of container security with an emphasis on the fundamentals, right? The difference, I'll highlight the difference between containerization, virtualization, the pros and cons of containerization from a security perspective, the challenges you're going to face with securing and monitoring containers throughout their life cycle, from all the way from the container registry all the way through to production. We're also going to explore the concept of container escape briefly. We'll review the role that kernel namespaces play, as well as control groups. The role they play to enforce, things like segmentation, controlling resource allocation. Then we'll gain an understanding of a container's runtime behavior and the importance of implementing, safeguards, including least privilege, to promote container isolation. I use a vulnerable API called Pixie. You can use any container. It doesn't really matter what you use if you want to kind of reproduce what I did. And essentially, one of the reasons that I did this is so that I can get a deeper understanding of the behavior. It's one thing to read about it. It's an entirely different thing to put hands on keyboard and actually see it, right? Because when you do that, it's hard to forget it, right? If you can forget something you read, but when you actually put hands on keyboard and you see the behavior real time, total effort, probably about 8 hours total. And I'm not including, troubleshooting, because some of getting Pixie going was a little bit challenging. But if you look hard enough on Google, you'll see the solution that I posted. I think it was on GitHub or somewhere, where it tells you what you need to do to get it going if they haven't fixed the problem already. But you can use any container you want. So a container image differs somewhat from an actual container. You build a container using a text file. It's a text-based script of instructions, usually called a Docker file if you're using Docker to do it. So an image executes a code in a container. So think of a container as basically a running instance of an image. It's actually a process. It's a Linux process if you're running it on a Linux host operating system. And so a runtime environment is the environment in which the program or the application is executed. It loads the application and runs it with the resources necessary for the program to run independently from any other container or from the host operating system itself. And basically it's software that runs other software, right? And so the cool thing about a container is that it's lightweight, right? Very portable, unlike a traditional virtual machine, which we'll dig into a little bit next. So containers and virtual machines, they do have similar resource isolation and allocation benefits, but they do function somewhat differently because containers virtualize the operating system instead of the hardware. And then containers are also much more portable, as I mentioned previously, and efficient because containers are much smaller in size, right? As a result, they're much more portable and they take up less space than a traditional virtual machine. They'll even boot up a little bit quicker, right? Containers are really an abstraction of that app layer. And that app layer packages all the code and all the dependencies together. Multiple containers can run on the same machine, and they share the operating system kernel. We'll talk about what the kernel is in case you're not familiar with it in a minute. And each container runs as an isolated process in what they call user space. So you have the kernel versus user space. User space is just the area of the operating system where an application runs outside of the kernel. So virtual machines, or VMs for short, are an abstraction of the physical layer. And they turn one server into many servers, right? The difference between a container and a virtual machine is that the virtual machine has a complete copy of the operating system, while the container does not. And so I'd like to highlight a couple terms. One is, of course, user space. It refers to the code in an operating system that lives outside the kernel. And the operating system kernel is the central module, right? It's responsible for managing memory, processes. A container is a process. You're going to hear me say that multiple times. If you don't remember anything, a container is a process. It manages devices, disks, system calls, much more. And the fundamental difference between a container and a virtual machine is that the virtual machine runs an entire copy of the operating system, as we mentioned earlier, including the kernel, while a container shares the host kernel, right? As a result, the container isolation is technically weaker than that of a hypervisor. Obviously, a hypervisor technology is a bit more mature, and the container itself is only relying on the kernel itself of that host operating system for container isolation. Just a sneak peek into what we'll talk about container escape. It's all about the kernel. If the kernel is not enforcing isolation, or if you don't have some sandbox that's sitting in between, like an app armor or a seccomp, or if you're hosting on GCP, a gvisor, then all you're relying on then is the kernel to enforce that resource isolation. So I want to credit Liz Rice, who wrote, authored the book Securing Containers. That's her image. So this slide represents a high-level overview of the common risks associated with containerization in containerized workloads, even including microservices. And managing secrets of all of these issues remains a significant challenge. But orchestration platforms like Kubernetes or Docker Swarm, and even some vaults like HashiCorp Vault, are now doing a pretty good job of secrets management. You can use AWS KMS if you're in AWS. And they've introduced the capability to manage secrets more securely without having to store them in config files or in code, or on disk itself, right? So do leverage when you're in a containerized environment. Do leverage a secrets vault to manage those secrets. This image belongs to Julia Evans. She's at Bork on Twitter. She publishes these zines on wizardzines.com, and they cost, like this one was $12, but it really does provide a nice a snapshot of what of the subject she's covering. Right, in this particular case, she covered container security, and in this image, she's talking about system calls and what those are. Right, so a container is a process, and any process to do anything on the operating system, whether it's read or write data to a file, open or change the owner of a file, create or kill a new process, execute another program, it's going to make a system call. It's making that system call to the kernel, telling the kernel, hey, this is what I want to do, right? And then the kernel is responsible for processing that system call. So there are hundreds of possible system calls depending on the operating system. The Linux kernel version of the operating system. And applications, containers included, don't necessarily need all of those system calls at their disposal, right? And certain system calls can be very privileged. And so you do want to limit privileges within a container. And do take the time to evaluate if it's a container that you're not aware of, somebody else built it, it's coming from a public registry. Do evaluate what it's doing over time and watch those system calls. And there's ways to do that. I'll show you how to do that in a second. Using strace. So strace is a Linux debugging utility, and it monitors the interaction between processes in the Linux kernel, which includes system calls to observe what occurs when a container is terminated. So that's what I did, is I just wanted to see what system calls are made when you actually terminate the container. But they call it a batch of system calls. So for every activity that a container or a process engages in, there's usually a batch of system calls that are pretty predictable, right? So you'll see that when we terminate a container, which is essentially a process, you'll see those system calls that it makes to the kernel when it actually terminates. All right, so here's where we actually peek under the lid. So a little setup is required to use strace. A word of caution, strace is very resource intensive, so don't run it on a production system, especially one that's highly transactional like a database. You may end up rendering it unavailable, or at least impacting the performance of that system. So you want to run sudo docker ps, and this lists the containers running on the host. Note that the process ID isn't listed by default. And to obtain the process ID, which is basically the ID that is associated with that container, you want to go ahead and run sudo strace-p, right, as it reflects on the screen. And with the to obtain the process ID, take note of the container ID rather, and then run docker inspect. And docker inspect is going to give you the process ID. Then run sudo strace-p with the process ID, in this case 4691. And then in another terminal, you can go ahead and terminate the running container, and strace captures all of the raw output listing the system calls made to the container, to the kernel rather, during the termination process. So here I run strace again, this time with the switch C, the dash C switch, right, to list all the system calls in table format. That's all it does. So you see all the system calls on the right there. Don't ask me what they mean. I didn't really look that up. But while using strace can be a really invaluable tool for debugging and understanding what's happening behind the scenes, strace, again, does have some limitations. The big one is the performance overhead associated with running strace, right? The other thing, it's not real time, right? It could be milliseconds to seconds off. So it's not really intended to be used for forensic investigations. You can, right, if you just want to see the system calls that something made, but not necessarily to build a timeline of what happened and when, right? It's just not that responsive. It does lack high level insight. So strace does give you a raw dump of the system calls, as you see on the right. Sometimes you might need a higher level view, or you need to know the sequence of function calls within the application itself. And for this, you might need other tools. Then you can also miss very short-lived processes, very short-lived containers. If a process is created and terminated pretty quickly, then strace might actually miss the system calls that you made because it's busy maybe evaluating other system calls. And it's not for all types of bugs. So strace is great for understanding system calls, but if your bug is purely algorithmic, or it's related to a process in memory, it's not going to really serve you well. And then there's some complexity when you're dealing with like multi-threaded applications, because when you're using strace, it may not put those in the right order, right? And it might miss some. So it's not perfect. It may not capture all the activity, as we just mentioned. And then there are some security concerns, because if there's some secrets, right, that are being passed with the system call, it might capture those as well.
So I understand this is a snapshot of time, I guess, because percentage of 100% at the bottom. Is this, you said it's not real time, so I'm guessing there's a slight delay. Is there a way to use pseudo strace to actually trigger on a potential vulnerability or actively being exploited system using the straces that you can tell that it's a container escape or something to that effect?
You could, but I wouldn't rely on the information. I mean, I wouldn't consider it complete or reliable, simply because it's not capable of, as I mentioned, capturing multi-threaded apps. It might miss very short-lived, containers that run for just seconds. Maybe it's busy capturing other system calls, right? And so I wouldn't rely on it for forensic investigation. To get some information, maybe you're evaluating what's happening offline. Yeah, sure. I would evaluate it over time because, as I mentioned earlier, you have what they call the batch of system calls that occurs when an activity is occurring, and maybe that thing that you're evaluating, that process or container you're evaluating, only issues that batch of system calls periodically, right? So there's some challenges associated with doing that. Make sense? Yep. Okay, so again, please note that everything in a file, or rather everything in Linux is a file, and file permissions do dictate, what or can access a file and what actions they can perform on them. So understand that containerized applications run as a process, and most run as root, right? Albeit with limited capabilities. And capabilities is a technical term in Linux, and I'll show you what that means in a minute. I'm not talking generally. There is a thing called capabilities that are permissions associated with a container, or a process rather. Consider that there are some rootless alternatives that are emerging that eliminate the need to run a container as root, but still an emerging technology, in my opinion. Otherwise, what you want to do is just take steps to limit permissions as necessary. Limit the fact that it's running as root if it doesn't have to, and then certainly limit the system calls that it can make and the capabilities that it's running with. So note that the set UID flag that's described here can be pretty dangerous because it might give an unauthorized user root access, right? So if you have the set UID flag set, it can at the very least access to run a program under another user. And so consider that the set UID flag does set the effective user ID of the calling process and can elevate privileges or allow a bad actor to elevate privileges in a container. So Linux does divide privileges traditionally associated with the superuser into distinct units known as capabilities, which can be independently enabled or disabled, or even filtered using a sandbox like a seccomp or AppArmor, which are free, by the way, and they're no cost, and open source. And so the capabilities can be independently granted or they can be independently removed. You can use the get pcaps command along with the process ID of the container to identify the capabilities that container does have, right? That's something that you can do offline as you're evaluating whether you can use that container in a production environment. You can reference the capabilities man page to learn more about each capability. And so while this container doesn't have the cap_sys_admin capability enabled, I highlight it here because it should be avoided. It enables many of the capabilities that are actually associated with root, even if the container doesn't have root. Make sense? You also want to avoid running containers in privileged or root mode, as we've mentioned a couple times. Though a container can run as root by default, several Linux capabilities aren't actually granted by default. So there is this thing called privilege mode, which means that if you're root in a container, you're going to have full privileges of root on the host system. So you do want to limit the use of that privilege mode flag as well. Here we talk about container isolation. So recall that a container, again, is a process. And there are 3 essential Linux kernel mechanisms to limit how a process accesses host resources, right? So control groups, namespaces, and then of course changing the root. So control groups are a feature of Linux that limits or accounts for and isolates resources, including CPU, memory, disk I/O, network. And so essentially it only allocates, or you can use it to allocate a specific amount of resources to a specific process or container. Namespaces are a feature of the Linux kernel. That's the thing that actually enforces isolation. You can view the namespaces available on your host operating system by using the lsns command, and you can see all the processes there with the PIDs. Each one of those is running in its own namespace. All you have to do is remember that control groups allocate resources and prevent overconsumption of resources, prevent a container from overconsuming resources, and then namespaces, which is a feature of the Linux kernel, actually is responsible for the isolation of that process, that container, in the kernel. So again, there are several namespaces. One example is that PID namespace, which provides processes with an independent set of process IDs. That's the thing that's actually, that's the process that's actually responsible for assigning the process ID, the PID. You can't see the host's entire file system from a container because the root directory is changed, at least in this use case, during container creation, effectively limiting the set of files and directories that a container can view. So who's here? Anybody heard of the container escape, just generally speaking? Yeah, so it's ultimately it's a result of a kernel that has a vulnerability, or essentially a container or process that has too many privileges, right? So recall that the cap_sys_admin, it's largely a catch-all capability. It does assign the capabilities associated with root. A lot of those capabilities are associated with root. And so as a result, it can lead to additional capabilities, and full root typically access to all capabilities or most capabilities. This container escape vulnerability materialized because of an issue with the Linux kernel, for which there was a patch. But container escape, it can result in from a container misconfiguration as well, typically over provisioning of permissions. And typical mitigation for a container escape vulnerability is patch the kernel, right? And then compensating controls will include minimizing the use of cap_sys_admin, or using a sandbox like seccomp or AppArmor. And basically think of seccomp or AppArmor as essentially a filter, right? It filters system calls. You can configure it to prevent certain system calls from being made to the kernel. So I'll make sure you guys get a copy of the slides. This is just we're going to go through a list of basically a checklist, things that you can do to ensure that your container environment is secure. And so you do want to scan images in the registry, for vulnerabilities. You want to apply any updates to third-party libraries, included with the application, right? Because remember, the container is running with all of the dependencies, all of the libraries that it needs. The only thing missing is really the host, a kernel, right? A host operating system. You're actually running the container on a host operating system. And then you want to make sure that those images are signed, right, to ensure that they're trustworthy. Keep the registry private, right? The registry is actually where you store all your containers. Keep it private if it doesn't need to be public. And avoid using publicly hosted, containers or images if you can. Build your own in a lot of cases if you're dealing with business critical, sensitive workloads. In certain cases you can't do that, but you can use some of the tools that we described today to at least evaluate whether the container is behaving, right? And then only allow these approved images to deploy to production. So securing the host itself, the host operating system, you do want to build that host operating system from scratch. You want to avoid relying on something, a host operating system that somebody else built, unless, of course, the workload is not exactly business critical, or it's going to process, store, otherwise work with non-public information. Configure that host operating system to some benchmark. The CIS benchmarks are widely available and free to download. You just got to give them your email address and your contact information. And try to use a minimal operating system like a Alpine or a CoreOS that's not running all the other bloat stuff, all the bloatware that comes with some Linux instances, like some of the Linux instances that are consumer oriented, right? Scan the host operating system for patches or for vulnerabilities, and then patch and configure away those vulnerabilities. Establish a gold image, host operating system that you can use repeatedly, right? Refresh that thing at least monthly, at worst quarterly. You want to apply the available updates to the host operating system frequently, though there are some shops that treat the host operating system and the containers as immutable, meaning that they don't really make any changes to their environments or workloads in production. What they end up doing is they patch in a non-prod environment, test, and then of course they deploy to production again, and then they tear down the old environments. That's the best approach. Not all shops are doing that, but that is the holy grail, the desired approach to working with containers, because again, they are easy to deploy. They're lighter, right? And it doesn't take long to go ahead and spin up a new environment that's been patched, tested, and is working as intended. Let's see. You want to apply available updates to the host operating system, as we said, and then do use a sandbox. Google claims that nothing that no host operating system where they've run gvisor has been impacted by a container escape vulnerability. That's what they say, right? And they say that in their documentation. So just consider that. Consider using some sort of sandbox, limiting the system calls that can be made to a kernel, especially if you have a container that's actually running as root and can't run without root. When feasible, you do want to run containers as non-root users. That basically eliminates or removes some of the capabilities that we talked about that are privileged, and then remove any unnecessary Linux capabilities that we talked about, especially if it is running as root. There is a way to go ahead and pare down the number of system or the capabilities that it's using. And again, in this case, a sandbox would be really useful. And then, although it's not as popular yet, still emerging, consider some form of runtime protection that runs on the host operating system to essentially secure that host operating system from the containers that are running on it. Do want to perform continuous cloud security posture assessment just to make sure that not necessarily the infrastructure, because it's not going to tell you if the host operating system is misconfigured, but at least the services within that public cloud, whether they're actually misconfigured. And then run containers on host dedicated to running containers. Avoid running other workloads on the same host operating system, and avoid mixing workloads that aren't really business critical or aren't processing or storing or rather working with non-public information on the same host operating system with other containers that aren't performing the same service, right? And two, you want to make sure that you're not running containers that are hosting public-facing web services, right? And then, of course, internal-facing services. You want to go ahead and avoid doing that too. Let's see. You want to add executables to the container image at build time, not runtime. And then you do want to run immutable containers to avoid configuration drift, as we mentioned earlier. It's just best just to redeploy the container. Don't worry about troubleshooting it if it's not behaving. Just redeploy it. So this one's pretty tricky and sometimes does require some sort of third-party solution, usually referred to as a mesh or some lattice. Basically, it's a solution that acts as a firewall, if you will, as a routing mechanism. Basically, what it does, it keeps containers from interacting with other containers that it doesn't need to interact with, right? And so you do rely on a firewall to restrict network traffic, enforce that mutual TLS to encrypt inter-container communication, especially if you're running containers on untrusted host operating systems. And then use those network policies to control which components can communicate. And again, you typically rely on some sort of mesh, right? Istio is an open source mesh that you can use to enforce mutual TLS authentication, to enforce that encryption, to prevent containers from talking to other containers that don't need to be talked to, right? And then treat those containers as ephemeral, here today, gone tomorrow. That's what ephemeral means. And refresh them often, especially if you want to address a vulnerability in a container in a host operating system. Again, do that in a non-production environment, in the pipeline, and then redeploy to production. Just the easiest way to do that.
So you say refresh them often. Define often.
As often as you think you should. How's that?
Okay, we're going to be scanning them for vulnerabilities.
You're not scanning a container for vulnerabilities, right? You're scanning offline, or at least you know that you're scanning your registry. You know that that container image has a vulnerability, right? If that's the case, then fix it and then redeploy to production. So as often as you need to.
So we shouldn't be scanning runtime containers that are actually in production.
It's not my preference, right? If you're treating your environment as immutable, that includes scanning, right? It doesn't just include patching or making a configuration change in production. That includes scanning. I consider scanning an active, intrusive event, right? And so if you truly treat an environment as immutable, then that includes not scanning it in production, right? You're just introducing traffic that doesn't need to be introduced, right? Scan your images in the registry. Scan your host operating system offline. If you detect a vulnerability, then go ahead and fix it and redeploy.
Is that to say that you should be resolving those issues upstream before you propagate them out to the
Yeah.
environment?
Yeah, exactly. So basically, shift left, right? So addressing it in the pipeline as far left as possible, usually in the registry when you're talking about a container. And so you're scanning the registry, you identify a security vulnerability. Maybe you're scanning in some non-prod environment, because your registry is not runtime, right? So at least scan it in a staging environment, test environment, scan there. But then, of course, as you identify security issues, whether they're configuration related, patch related, code related, at that point, instead of making the change in prod, make the change in non-prod, and then, of course, redeploy. Run it through your unit test, functional test, integration test, and then redeploy. Yeah. Let's see. Cool. All right. So again, secrets. Secrets is really challenging. It's not uncommon for secrets to end up hard-coded in code, hard-coded in config files, on disk, right, in text files. The best approach is to place it in a vault of some sort. If that's not possible, try to keep it in memory, right, and not write it to disk. Once you write it to disk, it's there for forever, right? Unless, of course, you redeploy the host operating system. You want to encrypt these secrets in a purpose-built secrets vault. Some of the orchestration tools that are commonly used to manage containers like Kubernetes, Docker Swarm, they're now beginning to include vaults. Or you can use a HashiCorp vault or the vault that your public cloud provider provides or provisions, like AWS does, Secrets Manager and such. Do encrypt secrets in transit when you do transfer them to containers or host operating systems. Don't pass it over the network unencrypted. And again, the optimal approach is to pass secrets and without writing them to the file. What did I say here? The optimal approach. if you have to write it to a file, then the optimal approach is to go ahead and write it to a file that's accessed through a temporary directory in memory, right? Held in memory, and then avoid writing those secrets to the disk itself. And that's all I have. Any questions, guys? Yes.
Could you define what a registry is?
Yeah. So a registry is where you actually store all your container images, and a registry can be public or it can be private. A public registry is available to everyone, right? The general public to download. People can contribute images to a public registry. A private registry is actually held privately by an organization, typically a company, and only used by that company. And that's where you can introduce trusted versions of container images so that your developers, your engineering team can deploy them to production. Does that answer your question?
Yeah, you know, you can go out to Docker.
Yeah,
now,
Docker has a public.
And the public registry, I'm not sure everything out there is trusted.
It's not. Yeah, I can.
Yeah.
Yeah, it's not.
But if you would keep your own private registry for things that you clear, and when you talk about scanning left, if you're on the left side of scanning, you're going to do that before you
Yeah.
put it in your private registry.
Yeah, you want to scan all the images in the registry, but remember, those scans are you're scanning something that's not in runtime, right? And so you do at some point want to scan them as well in some non-prod environment in runtime after you've deployed it, right? Then once you are confident that you don't have any configuration-related vulnerabilities, patch-related vulnerabilities, code-related vulnerabilities, at that point, feel free to deploy it into prod. Yeah. Any other questions? Yes, sir.
Do you have experience with clients using, like I know on GCP specifically, they have the premium tier of like Security Command Center where you can do real-time threat monitoring with container threat detection. Is that something that you recommend like in addition to you scan it before, like as you're building
Yeah.
image for misconfigurations and vulnerabilities, but then you're
Yeah.
also continuously monitoring for like malicious scripts or signs of like coin mining or like
Yeah,
whatever
absolutely.
it is.
Yeah, of course.
Scanning, right?
There's a talk out there on SANS, and all you have to do is register with SANS. I forget, Henderson's his last name, the instructor. They have 2 talks out there on container security monitoring. And yeah, there's a few, I do recommend it. I don't necessarily think that it requires, a commercial solution to monitor your containers. There are different ways to do it as well. You can use a sidecar, which is essentially a container that runs in the same host operating system, whose sole responsibility is to collect and process logs, right? Yeah, I do recommend that you do some degree of continuous security monitoring in your environment, especially if your environment is not as ephemeral as you would like, right? If it's static or long-lived, right? Because the longer you run that environment, the greater the risk is that something can or will go wrong in that environment. Now, if you're redeploying on a pretty continuous basis, security, you're going to have to get really creative around security monitoring because it becomes, it's not impossible, but it can be frustrating to figure out what happened when a container or even the entire host operating system is no longer in production. Make sense? Any others? All right. Well, I appreciate your time. Thank you very much. Yeah.